This is Chapter 6, Security Operations and Administration, Part 2. We'll talk about data classification standards. Classification is the duty of the data owner or someone the owner assigns. The system owner is the person or group that manages the infrastructure. Classifying information criteria. First is value. You can define the value of information by several different measures: the value to the organization, the value to competitors, the cost of replacement or loss of that data, which could be expensive, and the value to the organization's reputation. Sensitivity. This is the measure of the effect that a breach of the integrity or the disclosure of information would have on the organization. Organizations can measure sensitivity in many ways, including liability or fines, reputation, credibility, or loss of market share. And criticality. This is the measure of the importance of the information to the mission of the organization. What would happen to the organization if the information were lost? Information classification objectives. To identify information protection requirements, to identify data value in accordance with the organization. Another objective is to ensure that sensitive and/or critical information is provided appropriate protection and controls. To lower costs by protecting only sensitive information. We don't have to give every piece of information in an organization top secret or the highest standard of protection. To standardize classification labeling throughout the organization. That's important because in one part or one department, a document which ought to be confidential might be open for anybody to see in another department, and that could create confusion. And to alert employees and other authorized personnel to protection requirements. And lastly, to comply with privacy law and regulations. Some examples of classification in the U.S. government: unclassified, restricted, confidential, secret, and top secret. Obviously, a private organization in the private sector, this is not standardized, but they would not have to have all those kind of levels of classification. Public would be like once we create a product and we're going to let people know about it, that would have at that point it has low security because we want people to know about our new products. Private might be medium, only within the company. Nobody else outside the company can know this information. Confidential could be very high. That could be a brand new trade secret or product before it's ever released to the public. And maybe only a few people, maybe those in research and development or other parts of the organization have access to that kind of information. Let's talk about configuration management. This is the process of managing all changes to computer and device configurations. It evaluates the impact a modification might have on security. As a security professional, your job is to ensure that you adequately review all system changes, ensure that configuration changes will not cause unintended consequences for security. And those two are important. So those two are crucial to what you're going to do with configuration management. A hardware inventory and configuration chart. A decision to roll out a new patch, service pack, or release will be complicated if you can't find, update, and test every affected device. You need to have an up-to-date map or layout of the configuration of the hardware components. Copies of all software configurations, which are necessary so you can examine changes and updates planned for one device in terms of their impact on other devices. And then regularly check for any available vendor upgrades and service packs. The change management process. Let's talk about configuration control, the management of the baseline settings for a system device. Baseline settings meet security requirements. Change control, the management of changes in the organization. Unmanaged changes introduce risk because they might affect security operations or controls. An improper change can disable the system or equipment. Change control ensures that any changes to a production system are tested, documented, and approved. So we'll talk about change control management. You want to communicate change management procedures and standards effectively. It can be reactive or proactive. Reactive management responds to changes in the business environment. The source of this kind of change is external. Some examples include changes in regulations, customer expectations, and the supply chain. Proactive. Management initiates the change to achieve a desired goal. The source of this change is internal, such as the adaptation of new technology. This occurs on a continuous, regularly scheduled release or program by program basis. You need to have change control committees. They ensure changes are properly tested, authorized, scheduled, communicated, and documented. The committee oversees all proposed changes to systems and networks. It approves changes and the schedule for implementing the changes. In this manner, you cannot make changes to a system, network, or application without the proper review, funding, and documentation. In cooperation with IT, the committee provides the oversight to protect the computing resources and the data contained within those applications and databases. As part of the change process, key members meet with counterparts from the IT organizations to review upcoming plans and ensure you have properly evaluated all changes. Change control procedures. You start with the request. In the request stage, you should describe all proposed changes in writing and submit the change request to the Change Control Committee for review. You should never make a change to a system without approval. Then we go to impact assessment. The impact assessment stage evaluates the effect of the change on the budget, resources, and security of the system or project. We then go to approval. The approval, or in some cases disapproval stage, is the formal review and acceptance or rejection of the change by the Change Control Committee. Then we go to building and testing. The build test stage is the actual development or building of the change according to the approved change document. You then must test the change to ensure that it does not cause unexpected problems for other systems or components. This testing might include regression testing and an in-depth review of the security of the modified product. And finally, implementation. Well, that's not finally, we have one more step, but implementation, once you test the change and approve it for release, you can schedule the installation process. This is where adequate separation of duties ensures that no one person can make the change without proper review and oversight. The final hurdle is notifying management that you have made the change successfully. And finally, the last step is to monitor, which is the arrow on the bottom of all these larger arrows. In this stage, you must monitor all systems to ensure that the system, program, network, and other resources are working correctly. You should address any user's issues or requests using your organization's problem resolution procedures. Monitoring might identify the need for future changes. This restarts the entire change control process. Now, there are change control issues. Peer reviews. Ensure that a peer or another expert double checks all changes before you put them into production. Peers can often catch problems before they make it to the testing phase. Backup plans. Boy, I've had to have these when I installed software in my career. There were several times where we installed software and discovered that it didn't work the way it was supposed to, or it didn't work the way the vendor, like IBM, said it would work, and we had to back everything out and restore the system to its prior state, and then figure out what was wrong and correct it, and then do it again. This actually happened at least several times on software IBM gave us, where we'd have to install it again the next week after the errors were corrected. Again, these ensure that if the change doesn't work properly, a plan exists to restore the system to a known good condition. In spite of the best control procedures, you may accidentally release changes that have unintended effects. You must know how to undo or back out of a destructive change, which is really to uninstall everything and restore everything that the system to its prior state. And lastly, documentation. Keep documentation current to reflect the true system's design. You must You should keep backup copies offsite as well. Documentation is necessary to understand how the system is supposed to operate. So we'll talk about application software security. Processes for software development, the system lifecycle (SLC) and the system development lifecycle (SDLC). The steps are similar with a few key differences. SLC includes operations and disposal. SDLC ends with the transition to production. Now, why perform the system lifecycle? The main reason is to reduce or avoid costs. Consumers of commercial software products will see lower costs because you will need to deliver fewer patches and fixes. Also, fewer losses due to weaknesses in the software that attackers can find and exploit. Vendors of commercial software will see lower costs because they require smaller support staffs and have lower warranty and product maintenance costs. So let's talk about the entire system life cycle as shown here. Project initiation and planning. You need to plan to ensure you have necessary resources available. You should address threats, vulnerabilities, risks, and controls here first. Functional requirements and definition. This is the what if phase. Always state requirements using positive terms, such as the program must handle some data or perform some function. You need to think of what the program should or will do when the data doesn't meet specifications. System design specifications. Here, the project is broken into functions and modules. You have to consider the type of hardware on which the system is going to run. Security issues here include physical security of the hardware and network. Security also has to account for all the possible platforms. It's not enough to say the project is limited to Windows and Linux. Build or develop and document. Coding standards should include standard libraries and function calls. These should also include industry standard solutions for items such as cryptography, hashing, and access control. You need to secure code in development so only developers have access and so that you grant access only on a need-to-know basis. Even developers should have access only to parts they need to see. Acceptance testing. Create a test plan during functional design. It must include testing to make sure new programs provide necessary security and, where applicable, privacy. People responsible for tests cannot be the developers. Implementation. Here, developers will be working on the delivery of training and assistance to users and help desk personnel. Operations and maintenance. Maintenance operations and the help desk personnel are usually the first to know of a problem. They need to be able to track issues that come in and be ready to report their results to management. This procedure fuels the change management process. These personnel need to know the differences between a request for a change, a software malfunction, and a security weakness or breach, and how to handle each of them. And lastly, disposal. When component parts reach the end of their lifespan, upgrades become necessary. And if you have too many upgrades, then the software or the hardware is getting to a point where it's useless and may not be supported anymore. So you need to ensure you have the procedures ready to sanitize the media and dispose of it securely. Testing application software. You need to test for all expected and unexpected actions. You need to handle errors correctly. You need to perform tests to test the maximum load on the system, including transaction volume, memory allocation, network bandwidth, and response times. You need to keep production or sensitive data secure during the testing. Now, one type of testing input vulnerabilities is called fuzzing. This is the practice of providing random input to software to see how it handles unexpected data. It can help you identify input vulnerabilities better than testers trying to think of bad input. When I worked at Savannah Foods and Industries, we used to call this terrorist testing. We'd just key in anything and see what would happen. Catching vulnerabilities. You need to thoroughly evaluate any change to your environment, formalize the process for procuring new equipment, follow the guidance in your data policies, Review a system throughout its life cycle to ensure that it meets its specified security certification. Make sure management officially accepts the system, which is called accreditation. Let's talk about systems procurement. Sometimes changes cause unintended side effects, allowing new vulnerabilities to enter a system. So you need to thoroughly evaluate any change to your environment to ensure it doesn't introduce new vulnerabilities. Procuring equipment is a critical role of the security professional, but the process has to be handled properly. You need to do the following. Evaluate various solutions that are available. Evaluate vendors in terms of maintenance, support, and training. Use what's called the common criteria to ensure that you simplify the evaluation process. The common criteria, this allows you to formalize the procurement process. The U.S. government created a series of computer security standards known as the Rainbow Series due to the bold colors of the covers of its documents. The Red Book describes the components of a trusted network infrastructure, or TNI. The Orange Book discusses maintaining access control and confidentiality in a classified system. Both used a series of evaluative levels like C2, B3, and so on, and vendors had their products evaluated against these levels. The common criteria have a series of increasingly more difficult evaluation assurance levels, or EALs, numbered from 1 at the lowest to 7 at the highest. Leading vendors within an industry, for example, firewall industry, collectively create a standard, ideal, and perfect solution. Any vendor can have its product evaluated against the standard to receive an EAL rating. You need to monitor your vendor contracts and service level agreements. Correctly install equipment and formally accept it at the end of the project. Follow the organization's procurement procedures to ensure a fair purchasing process. And monitor systems and equipment to identify equipment that is reaching the end of its life cycle so it can be replaced. Data policies. What do you do when you no longer need or you can use data? The best action is to follow guidance in your data policies. Policies that cover data management should cover transitions throughout your data's life cycle. You need a solid plan that includes sections on retention and storage as well as disposal. You can overwrite the data on the media, called wiping, or destroy the media, but wiping or overwriting doesn't really destroy the media. It's not perfect. There are two methods to dispose of data in a secure way. Degaussing, which is applying a strong magnetic force to a magnetic media, or physical destruction, such as just drilling a hole through an entire disk pack so the disk won't turn and thus cannot be read. Software development and security. Software development and security in an application must perform these tasks. Check user authentication to the application. Checks user authorization, the privilege level. Has procedures for recovering database integrity in the event of a system failure. Handles errors and exceptions consistently and does not allow any error or exception to go unhandled. Unhandled exceptions can reduce an application's security. You need to plan for approaches to handle all errors and exceptions with standard responses. Give users a consistent error response and provide clear explanations and instructions. Empower your users to make the right choices. You need to validate all input. Never accept any input from a source without validating it first. If the data fails validation, throw it away. Do not try to sanitize it. Aggressively sanitizing input data can help avoid many types of attacks. That means you have to validate data on the client and on the servers. Attackers can often change data as the data travels from a client to the server. Validating it on the server again is the only way to be sure that the data are valid. Some attacks that depend on weak validation includes cross-site scripting, or XSS. This is an attack in which an attacker inputs client-side script code to a web application. The code would then be viewed by other users, and their client software would execute the script instructions. The cross-site scripting attack exploits the trust users have for a server. Cross-site request forgery, XSRF. Similar to the cross-site scripting attack, an attacker provides script code that causes a trusted user who views the input script to send malicious commands to a web server. The XSRF attack exploits the trust a server has in a user. Structured query language, or SQL injection, an attack technique in which an attacker provides malicious SQL statements to access unauthorized data or carry out unauthorized commands. You define secure configuration baselines. When you release your application to end users, you need to provide a documented set of configuration settings that define a secure baseline or starting point. Provides guidance on hardening your application. In addition to providing a secure baseline, you need to offer guidance on changing of configuration settings that will keep your application secure. It should also provide guidance on further configuration settings or the addition of external controls that will increase your application security. And provide and apply frequent patches. You need to ensure that you apply the latest security patches for your environment. It should also provide frequent security patches to the users of your application, along with a convenient method of applying patches and managing the patching process. Secure development models. The two most widely accepted models are, and if you took IT 3234, you would know this, the waterfall model and agile development method. And of course, if you haven't taken it yet, you will eventually encounter this in that course. The waterfall model is based on traditional project management practices in which extensive planning precedes any development. Progress through a project moves forward along a well-defined path. The agile development method is a newer family of project management approaches that depend on very short sprints, as they call it, of activity. Agile works well in very dynamic environments where requirements change and are often revisited. So here we see the waterfall model where you go from requirement specification to design to construction to integration, testing and debugging, installation and maintenance. Sometimes some of these steps are combined, but one thing you notice is that there's no arrow going back. In other words, in the waterfall model, once you start going forward, you really can't go back. Now, there are some variants of this that do allow you to go back. For example, if you have a problem in testing and debugging, you go back to either design or go back to construction. But for the most part, it generally looks like this. Now, the agile software development method is different. You have initial planning, as they show a blender here, because in the blender, you really get your requirements and analysis and design, implementation, testing, a demonstration evaluation, and that's the sprint, and then out comes deployment. So it runs in a series of sprints instead of long project schedules. Organizations that use Agile produce smaller deliverables more frequently and can evaluate a large project in terms of its individual pieces as they are completed. Sprints are usually 1 to 4 weeks in duration. Here you focus on the focus on frequent delivery makes it possible to see and use pieces of a large software project as it matures over time. So in summary, we talked about the role of security administration within an organization, the components of an IT security policy infrastructure, data classification standards used by organizations, the Department of Defense, change management and configuration management, and the systems lifecycle, SLC, and the system development lifecycle.